how to solve systems of equation using row-reduced echelon form. So here's my system of equations right here in the upper left. This is what we're going to start with, and we're going to start working this through. I have all the pieces already put up here. I'm going to kind of walk through the process of how we do that. Our goal is to get down here to what is called row-reduced echelon form. A lot of times that's abbreviated RREF. The idea behind row-reduced echelon form is we want a diagonal of 1s, and we want everything above and below that to be 0. So we're going to start with the 1 being in the upper left, and then work our way down to the lower right. And then all the other quantities in there are going to be zeros. So what I did is I first took my first equation that makes my first row, and I just take the coefficients from there. So 3, 2, 4, 12, there it is right there. 2, -3, 3, and 6, right there. And here we have understood coefficients of 1, 1, and 1 with ours, with x, y, and z. And I just pull those down here along with this answer column, if you will, or the constants is actually what you have here. So this last column here is always the constants. Notice these are all in the same form, right? They're all in the same format there. That's important, that they need to be in the same format. And then I have a column of x's, a column of y's, a column of z's. They're coefficients. And then a column of constants. This is an augmented matrix because I have put the constants onto the end of the matrix. Okay, that makes this particular one 3 by 4. So my goal is this. This is where I'm starting with, right here with this, what I'm designating as M1, matrix 1. So my goal here is to get these two positions right here, the first column, second row and third row, I want those to be zeros. So I'm going to take row 2, and I'm going to add -2/3 of row 1 to it. That's going to be 3 times -2/3 plus 2, which gives me 0. The next one I'm going to do something kind of funky, just to kind of point out that you can do things a little differently. Here I'm going to say row 3 is going to be row 1 plus -3 times row 3. Now I did that because 1 and 3, well, 1 times -3 gives me -3, plus 3 gives me 0. So if I multiply the third row times -3 and then I add it to the first row, and I make that my new third row, it's going to give me a 0 in that first column, third row, which is what I want. And then all the other pieces kind of cascade through there as I go. Now, going from M2, which is these modifications I made right here, to M3, the only thing I did was I saw, well, I have these fractions here, and you don't have to do this, but here I'm going to say row 2, that's going to end up being 3 times row 2. Now, that gets rid of all those pieces. Notice that I didn't get rid of the signs. I could have done that too. I could have multiplied. I can do any process I want to rewrite these and rearrange these. But these particular ones seem to make good sense to us, or to me at least. So that's what I'm doing, is I got rid of my fractions. Does that make it easier? Well, that's really debatable. It's whether how much you like and how much you enjoy working with fractions. You're going to see here in a second that we're just going to reintroduce fractions all over again anyway, so it doesn't matter. So going from M3 to M4. And again, since this is a video, feel free to pause and try to think, well, what did I do next? What's the difference between M3 and M4? Now remember, our goal is to get a 0 here, right? Well, I have a 0 there. That's really the only thing that's changed between these two matrices, right? So how did I do that? Well, how do I get a 0 there? Well, we already got rid of that first term, so what I'm going to do here is I'm actually going to do something to row 3. And I'm going to be using row 2 to do it. So I'm going to do row 2 plus row 3, but I need to do something to row 2, or I need to do something to row 3, either way. So one thing I could do is I could look at this and I say, well, they're both negative. I need the signs to be different. So whatever I do, I need to multiply by a negative. All right? I'm going to do this to row 2. And now, currently I have 13. So I'm going to make this divided by 13. That way the 13s will cancel. And I need it to be 5, so I'll put a 5 there. Now when I do that, I get to this right here. Now, some of us are probably looking at that and saying, well, that's not actually what you would end up with. Well, there's an additional piece here. The other thing that I did to this row before writing it out was I also came through, and that's, that's ended up going to be 13, right? I also took row 3, and I said I'm going to do 1/13 of row 3. And when I do that, it's going to get rid of all these fun little fractions for me. Actually, I think I did 13 over 138 is what I end up with, because that's what you end up with right here in this spot. Remember, I want it to be a 1. So I went ahead and did that. Now I actually know the value of z already. So if my goal here was to find z, I'm done. Right? I have that value. But now I can use that value, if I were doing this from a substitution perspective to solve this system, I can just go backwards up the equation, which is what we did here. So I'm going to use z to isolate y, and then I'm going to use z and y to isolate x. So looking at from my fourth matrix to M5 here, well, what did I do? Well, first thing I did was I said, you know what? I can take row 2 here, and I can make it row 2 plus some quantity of row 3. Because the only thing that's there is that z value. So all I need to do, well, in this case, I just make it negative, right? I'm just going to get rid of that for me really easily. And now I have a 0 there. Then with row 1, I'm going to make row 1 plus something is happening to row 3, right? Well, what's happening? Well, I just need it to be a negative 4, right? And that's going to get rid of that piece for me. So there, I'm set on that one. So at this point, the only thing that's left here is I have a 13 here. I need a 1. I have a 2 there. I need a 0, right? So, well, what do I need to do with that? Well, to get from M5 to M6, I did 2 things. The first thing I did was I made row 2 equal to negative 1/13 of row 2. Now I have a 1 there. Then I made this row 1 here. I made it row 1 plus negative 2 of row 2. And I just added those pieces together, or subtract them as the case may be. And that gave me this value. Now, once again, this is a lot going on here. And this entire process, and I do a lot of work with matrices, this took me a while. So don't think, well, he's going so fast. Yes, I am, because otherwise you're just watching me write a bunch of numbers down. Pause the video, rewind the video, rewatch sections of it, get these numbers independently of me, make sure that you're coming up with the same values. Notice I did switch over from fractions to decimals. A lot of times that's easier in these instances. Sometimes it's not, though. So you might find that fractions work better for you. So at this point, the only thing left to do is this first row. In row 1 there needs to be row 1 divided by 3. And when I do that, I end up with my final value. And the only thing left to do here is to point out that x is negative 0.3109. Y is 0.683, and z is 2.89. And there I have solved this system of equations using row-reduced echelon form. I hope you enjoyed this. I hope this was fun. I hope it wasn't too tedious, although this is a long process. Take your time with these problems and pay attention to little details. It's really easy to do silly things like add 2 plus 2 and get 5 when you're doing all these different calculations. So just take your time and work through it. All right? Take care.